Hello everyone, and welcome. आज के इस विश्लेषण में we're going to literally dive right into the heart of physical reality. Atom के center में आखिर क्या है? The nucleus, right? Now, if you're the kind of person who loves figuring out how the universe actually works at its most fundamental level, this explainer is going to be incredibly satisfying. हम लोग nuclear charge density को decode करने वाले हैं. And trust me, by the end of this, the way you picture the building blocks of matter will be completely transformed.
Okay, so let's get right into it. Think about it for a second. जब आप एक atom के nucleus को imagine करते हो तो दिमाग में क्या image बनती है? Think back to your high school chemistry or physics classes. Most of us imagine this perfectly packed cluster of protons and neutrons, like a hard, perfect little marble. But क्या नाभिक एक ठोस गोला है? Is it really a solid sphere like a billiard ball? We're taught it has this hard, definitive edge. But as we look closer at the actual physics describing nuclear charge distribution, well, we realize our childhood assumptions need a massive upgrade. The universe, it turns out, is a lot less rigid than we thought.
So what's actually going on here? The reality of the nuclear charge is super interesting. According to the data, the positive nuclear charge is actually nearly constant from the very center all the way out to the periphery. But जैसे ही आप outer edge पे पहुंचते हैं, it shows a drop that is rapid but, and this is the absolute key here, not abrupt. It indicates a diffuse surface. यानी सतह एकदम तीखी नहीं है बल्कि थोड़ी धुंधली है. It doesn't just suddenly stop like the sharp edge of a table, it just kind of fades up.
To truly map this out, physicists use mathematics to define exactly what this looks like, known as the nuclear charge density. They represent it with the Greek letter rho. It's given right here by equation 1.3. Now listen, if आपको math पसंद नहीं है, please don't panic. We aren't going to get bogged down in heavy calculations in this explainer. This formula is literally just describing the exact physical reality we just talked about, a constant, solid center, and that beautifully blurry, fuzzy edge.
Let's break this down so it actually makes physical sense. Variables का real world में क्या मतलब है? First up, we have the small r. ये बस आपका radial distance है, meaning how far out you are from the absolute center of the nucleus. Next, we have capital R. ये एक बहुत ही important milestone है. It's the exact radius where the density drops to exactly half of what it is at the core. And finally, we have A. This is known as the diffuseness parameter. आप A को एक fuzziness dial की तरह सोच सकते हैं. Mathematically, ये dictate करता है कि वो outer boundary आखिर कितनी blurred या diffuse है.
And this perfectly shows how we actually measure that boundary zone. According to our source material, the entire extent of this falling portion of the charge density, that whole fuzzy, fading edge, is taken to be exactly 4 times the diffuseness parameter, 4a. Agar aapka a bada hai, then you get a much wider, fuzzier edge. Agar a chota hai, to wo falling portion shrink ho jata hai. The edge gets relatively sharper, but again, never perfectly abrupt. It's literally a mathematically precise way of measuring a blur.
Let's actually visualize this so it clicks. We're looking at a graph plotting the variation of nuclear charge density against the radius. Direct your eyes to the y-axis on the left. That's rho of r. Look at the starting point of that dashed line right up at the top. This represents the density at the absolute dead center, rho 0. अब देखिए, कैसे वो dashed line बिल्कुल straight right की तरफ जाती है? Perfectly horizontal. This beautifully shows us that right in the core, the positive charge density is perfectly flat. It's packed uniformly with zero change. Okay, continuing our journey along the x-axis at the bottom, the radial distance r, as we travel outward from the center, the density stays completely flat. जब तक हम एक specific point पर नहीं पहुंचते, labeled capital R. Now follow that arrow straight up from R and over to the y-axis. Look at exactly where it aligns. It points right to rho 0 divided by 2. ये perfectly उस चीज को visualize करता है जो हमने पहले discuss की थी. R is that critical halfway mark where the density drops to exactly 50% of its original core value.
Now, let's trace the final part of this story. Watch what happens to the dashed curve immediately after it passes that halfway mark at R. It takes a massive dive downwards. It falls incredibly rapidly. But look closely at the shape of the curve at the bottom right, जहाँ वो x-axis के पास आती है. It doesn't hit the axis at some harsh, sharp angle. It gracefully swoops down and just trails off. ये visually उस 4A boundary को represent करता है, the rapid but completely non-abrupt dive. It is absolute proof that the nucleus doesn't have a hard shell, it has a diffuse fuzzy edge.
So we've looked at the math, we've traced the graph, and I think it's safe to say we've completely shattered that old billiard ball illusion. डेंसिटी कोर पे कांस्टेंट है, कैपिटल आर पे आधी हो जाती है और फिर 4a के डिस्टेंस में स्मूथली फेड हो जाती है. Which leaves us with a truly fascinating, mind-bending reality about the very matter that makes up you, me, and literally everything around us. If the edge is just a mathematical fade, a diffuse blur, तो फिर नबी का समय खत्म कहाँ होता है? It's a wonderful reminder that down at the quantum scale, nature totally prefers beautiful, fuzzy gradients over sharp, hard lines. Thank you so much for joining me in this explainer. Keep asking questions and keep exploring the wild structure of our universe.